Hello everyone. In the previous video we have discussed about the black body radiation and photoelectric effect. Today we will discuss about the Bohr's model of atom or rectification of defect of Rutherford atomic model. You can say that Bohr's atomic model. Bohr's atomic model. Postulates of Bohr's are Bohr postulated that first, electrons revolve around the nucleus in some discrete path that is fixed path called energy levels or orbits. Electrons move in the discrete path. This level is called, the different orbits are called energy levels because the energy of this path is fixed. While revolving, electrons do not radiate energy. There are many. These are called energy levels. These are energy levels. Or orbits or shells. This is denoted by K element. As you know that first, second, third, fourth are denoted as one K element. While revolving, when the electrons revolve around the nucleus, they do not lose energy. The energy is not changed. While revolving in a discrete path, in an energy level, electrons do not radiate energy. Radiate energy or lose energy means in the discrete path electrons move in a circular path without radiating any energy or losing any energy. The energy of that path is always fixed, but electrons may jump from one path to another. Third postulate is electrons when gains energy it moves from ground state to excited state. Ground state means if an electron is present in the first shell, there are many shells are present in the atom. So if it is present in the first cell, it may gain energy and jump to the second or third second or third or fourth energy levels, different energy levels. And when they lose their energy, they excited, this is ground state and this is excited state. If this electrons move from the ground state to the excited state, which is first, this is first shell, this is second shell, to the second shell, then it loses energy in the form of radiation and finally falls into the ground state, finally comes into the ground state. If we are going to take the spectra of this type of radiation, this type of spectra is called emission spectra. There are two types of spectra. I am going to give the spectral spectra. There are two types of spectra: emission spectra and absorption spectra. Emission and absorption spectra. In the emission spectra, when this electron get excited, they loses energy in the form of radiation. And if there is a spectrometer, a spectroscope, we can take the picture of this type of spectra. Like some lines are present in the spectra. Some lines are present in the spectra. Blue, green, yellow. There are several lines present in the spectra, and some black dark surface are present also. Dark surface of that spectra, this dark surface of this spectra, this is dark surface, dark or black surface, black line of this spectra indicates that some energy is absorbed in this and rest of the energy is radiated while this electron moves from the ground state to the moves from the excited state to the ground state, to its state. It depends on the excited electrons at which state it is present. Spectral lines are formed accordingly. In hydrogen spectra, there are 5 types of spectral lines formed. We will discuss later. And if it is absorption, just look at this. Electrons, when gain energy, it moves from ground state to excited state. It reaches to the excited state. Sometimes, if we give energy to the atom and then some energy, if we think again, if this is the spectra, this is the atom of an element and the electron is present here. Electron is present in the ground state. Then when we irradiate or heat this atom, it reaches to the ground state, to the excited state. It may be at one state more than the ground state, or 2 state or 3 state, it depends. It depends on the energy given to them. If it reaches to the ground state, to the excited state, it absorbs here. It absorbs some radiation or heat which we have given to this electron and reaches to the excited state. During this movement from ground state to the excited state, it absorbs. This atom absorbs energy, and the spectral line formed the spectral line formed by this type of radiation is mostly dark. Dark lines are more prominent. Dark lines are more prominent than the colorful lines. Dark lines are more prominent than the colorful line. Most of the region becomes dark and very few regions become colorful. It depends on the atom. If you irradiate sodium chloride, then yellow light is absorbed. Other than only a yellow band is present here, and other than that, all lines becomes dark. So it depends on that the atom or the compound on which you irradiate or heat them. This type of spectra is called absorption spectra. So electrons, when gain energy, it moves from ground state to the excited state. This is the third postulate of Dalton. If electrons jump from the lower to the higher state, energy is absorbed, and when it moves from the higher state to the lower state, energy is released in the form of, so the total energy and change in energy here is h nu, as we know that it is always quantized. So change in energy from ground state to excited state, the change in energy is h nu. And the fourth postulate of Dalton is both angular momentum of the electron, which is revolving around the nucleus of the atom, is nh by 2 pi. So the fourth postulate is the angular momentum of the electron moves in the circular path means, angular momentum means if it is nucleus and it is movement of electrons, momentum is mv, momentum is equal to mv, and if it moves when an object is moved in a circular path, then it is mvr. mvr is equal to h by 2 pi, where h is Planck's constant, m is mass of the electron, v is velocity, r is radius, and it is equal to, mvr is equal to nh by 2 pi. If for first cell, for first orbit, the angular momentum mvr is equal to nh by 2 pi. For first cell it is h by 2 pi. For second cell, this n is now 2h by 2 pi. You can calculate it. The angular momentum of the second cell is h by 2 pi. For third shell it is 3h by 2 pi. So it is 3h by 2 pi. The angular momentum is 3h by 2 pi. For fourth cell you can calculate like this. Fourth cell it is 4h by 2 pi, means 2h and so on. So 2h by pi or so on. 2h by pi or so on. So this is the angular momentum of different electrons in different shells. Now we can calculate the radius of the, let's start the calculation of radius. For calculating the radius of an orbit, let's consider an atom. This is electron at the center, proton at the center, and an electron. The distance from this electron to the nucleus is r. So from the center to this electron is r. So for calculating the radius of these two are together with an electrostatic force of attraction. So electrostatic force of attraction, electrostatic force is equal to centripetal force. Centripetal force. Centripetal force means these two. When an object moves in a circular path, it has a centripetal force. It experiences a centripetal force. Electrostatic force. As we know that electrostatic force is equal to K Q1 Q2 by R square, where K is a constant, Coulombic constant, and its value is 1 by 4 pi epsilon naught, which is equal to 9 into 10 to the power of 9 meter square per second square. So here there are two charges here, proton and electron. There are two charges, so the electrostatic force here is K ZE into E by R square, and centripetal force is mv squared by R. From here we can write that Z is K ZE squared by R is equal to mv square. This is our question number 1. By putting the value of V from here, like mvr is equal to nh by 2 pi. So V equal to nh by 2 pi, nh by 2 pi mr. By squaring it, it is n square h square by 4 pi square m square r square. Put the value of V here. K ZE square by R equal to m n square h square by 4 pi m square r square. This are cancelled, this and cancelled. Now we have ZE square, K ZE square is equal to m square h square by 4 pi mr. And we need to calculate the radius. So keep the radius here, and we can have from here r equal to n square h square by 4 pi square 4 pi square m k ZE square. 4 pi square m k ZE square. This is the radius of nth orbit. So here h is constant, pi is constant, mass m is mass of the electron, it is constant, k is constant, e electron, magnitude of electronic charge is constant. So these are, by taking the value of these all constants, we have r nth for n orbit. Radius for nth orbit is equal to n, these are n square, h square, pi square. By calculating these all, we have 0.529 angstrom value into n square, h square is constant but n square by z. This is the formula of radius for various orbits of atoms. Let us consider, but this radius formula is for single electron system. Bose give the radius formula for single electron system. For example, if you consider hydrogen atom, for hydrogen atom, there are different orbits present in the hydrogen atom. We can say that there are different orbits present in hydrogen atom. So, if we consider, this is angstrom, if we consider n equal to 1, and the mass, the z of hydrogen atom is also 1, z is equal to 1, then the formula for R1 for radius first orbit of the hydrogen is equal to, this is 0.529 into n square means into 1 square by 1 angstrom. This value we can say that this value is AO, or is equal to Bose radius. This A naught is called Bose radius. By considering this, we can calculate the radius of, if it is A naught, the radius of this orbit is A naught. The radius of the second orbit is 0.529 into 2 square by z is common, z is 1. So we can calculate directly A naught into 4, or we can say that it is 4 A naught. So radius of the R2 is equal to 4 A naught. What is A naught? A naught is 0.429 angstrom. A naught is equal to 0.529 angstrom, or you can say that 0.53 angstrom. A naught is equal to. By considering this value, the R3 is, what is R3? R3 is equal to A naught into, if it is N3, N is equal to 3, N is equal to 3, so 3 2s are 9, so it is 9 A naught. So the value of this is for the radius of second orbit. This is first, second, third, fourth orbit. The first orbit, the radius is A naught, the second orbit, A radius is 4A, third orbit radius is 9A naught, and for fourth it is 16A naught. 16A naught. The distance between first and second orbit is 3, and the second and third orbit is 5, and so on. The distance between the two orbits are different So let us consider the second example for helium ion, not for helium atom, it is for helium atom. This radius calculation is for one electron system. So it is radius of He plus. For He plus, Z is equal to, formula is Rn is equal to 0.529 into n square by z. That means angstrom. That means what if it is R1? n is equal to 1 for first orbit. It is 0.529 into 1 square by, here z is, for helium z is 2. So the 4 angstrom. So it is 0.529 by 2 angstrom, or we can say that A naught by 2, it is R1 is equal to A naught by 2. You can calculate the second, third and fourth orbit likewise. R2 is equal to A naught. For R2 it is 2 and Z is equal to 2 also. So for R2 it is A naught. A naught means 0.529 angstrom. You can also calculate the radius of lithium 2 plus or beryllium 3 plus likewise. So in your question you can calculate directly the radius of, if you remember the formula of this, and this is, if it is A naught, then you can directly calculate the different radius of one electron system by these formulas. Next is calculation of velocity. Or we can discuss the calculation of velocity and energy in the next video. Thank you.